Okay. Good evening to all of you and welcome for the today's session. Actually, I'm under the power cut, so I have to use my mobile. I'm Kamala Gunwadana, Council Member and the Chairperson of the Knowledge Sharing Subcommittee of Civil Engineering Sectional Committee. Now, we are at the 10th lecture. We are at the doorstep of 10th lecture of Medium Rise Building Designs and Constructions. Today we'll be explaining under the title Behavior of Coupled Shear Walls and Their Effectiveness in Tall Buildings. The next Tuesday program will be a different one since this program is designed for you all to step up for the next level of your design status. And Professor will let you know the details of it. I really appreciate the steps taken to share your knowledge about this specialty, dear Professor. I hope our gathering, our participants will extract whatever the most valuable lectures, details he delivers in this valuable series of lectures. Before starting the today's program, I request you all to mute your microphones always, except you need to ask questions. And actually, we face several disturbances over the past few lectures. So make sure that it is always muted. Thank you. I think Professor has joined now. Professor, you are there?
Yes, Miss Kamala, I'm
Hello?
here. I'm here.
Okay.
Yeah, I can hear you.
Right, Professor, over to you.
Okay.
Professor?
Yeah, okay, thank you very much.
Thank you so much. Yeah.
Yeah, just
Have
give
a
me 1
good
minute to set up my
evening for
camera
everyone.
so that I can.
Okay. Okay. Be patient for another 2 minutes.
Right. Now, last time we talked about many structural forms, but today we'll go into one of the most important ones that you can often use in tall buildings. So first I will share the screen. Can you see this note?
Yes.
Yeah, design of large structures, upper shear walls. So basically, upper shear walls occur when you have two walls aligned and there's a possibility of connecting those walls. So the simplest situation is you have only a slab. But in many instances, we have a floor to floor height of 3.2 meters, but the opening height is only 2.4 meters. Which means 2.4 to 3.2, 0.8 meters. We can have a beam of depth 0.8 meters and a width of about 0.2 or 0.225 or 0.25 meters. The reason is, in a normal building, you can use a shear wall thickness of 200. the minimum that is that you can cast, unless you have very special arrangement, like flowing concrete and steel shutters, special shutters or something, then you can even cast 160. But under normal situations, what you can easily cast is something like 200. With some great difficulty, you can cast something like 180, but it's pretty easy to cast 225. So we like 225 type walls. And if it is 250, you have no restriction. It's very straightforward casting. And then you'll find the reason is the cover that you need for enforcement. And when you look at Eurocode, they even request something like 10 millimeter variation in the cover. And if you allow all that, you might need something like 35 millimeter cover, unless you are using high strength concrete. So basically, even if you keep reasonably, if you are using reasonably high strength concrete, when I say high strength, I would like to say one or two words about it. Have I covered the concrete technology part earlier in the lecture series? Engineer Kamala? Or any other person? I mean, Engineer Kamala, can you just remember whether we covered the concrete technology part? Right. So basically, when you have coupled shear walls like this, what happens is, we can convert this coupling beam to a continuous medium, equivalent connecting medium. And based on that, you can work out a set of equations, the theoretical behaviors, and so on. Right. So basically, what happens is, you will get certain total moment acting on the structure, and that moment will be shared by two walls, and then there will be an axial load that will be transferred from this wall to this way and this way due to the behavior of the beam. Basically, beam is bending. To bend the beam, you have to apply a load, and that load will be represented by this. Finally, that load will be transferred to the center of the shear wall. So you will get a couple. But what you find is, even for a small n value, you have a huge lever arm. Because the lever arm is huge, you see that the bending moment is huge. So if the total outside bending moment is capital M is equal to M1 plus M2 plus n times the distance, let's say L, n times the L. So you will get a total of capital M. But now you see M1 plus M2 plus n times L is capital M. So if you want, you can get the addition of M1 and M2. M1 plus M2 is M minus NL. That means the total moment resisted by the two shear walls is now low. If you don't have coupling action, the total moment M is equal to M1 plus M2. But now what happens is, total moment is equal to M minus NL. And you can see these walls can be 3 meters, 4 meters long, and then you can have an opening of 2 meters, another 3-4 meters long. So you can get a lever arm of about 7 meters, and even for a small value of n, you get a huge reduction in the total bending moment. So because of that reason, if the bending moments are very small, relatively small than the individual situation, then you will find the deflection of the wall also should be low. So we will end up with a much lower deflection of the coupled shear wall. So the deflection can be sometimes 50%, 60%, 70% lower than the normal case. That is a huge advantage when it comes to controlling the acceleration and the the acceleration and the movements of the building. And we don't like a building that moves too much. And if you consider world famous building like Shear Tower, which is having 104 stories and about 1,470 feet height. You know, when you go to the 103th floor, that is the highest they can go in that building for under normal situation, and they had a radio station there because they could see the whole area around, the whole of Chicago could be seen from that particular floor. So they had a radio station, but the people who worked at the radio station used to say, oh, it's not that easy to work there because the building moves. So all the time building is moving and we could feel the movement of the building. And basically we do not like to work there, but you know, because it provided us 180-degree view of the whole city. No, we liked it because we could see what's going on in the city. Whole city we could be seeing, and we knew we can see how the helicopters are doing the surveillance operations and any car chases, anything, many things we could see. So we liked it, but not because of the occupant comfort. Not because of the occupant comfort. So you can see, couple shear walls could be very helpful. And the moment you couple two shear walls, the overall shear wall length is like something like 7-8 meters. They're huge, strong shear walls. And then coupling beam also can be something like 300 millimeter depth. And it can go up to about 800 millimeter, 900 millimeter. And if the coupled shear wall is strong, then you have to be careful as well, especially in high earthquake zones. Why? The reason is, now you can see there's a moment, capital M. But we are not designing the walls to carry capital M. We are designing, say, about 60% or 50% much lower capacity. So, in an earthquake, you'll find what is the weakest member in the system. The weakest member in the system is these beams. They are very weak. And in an earthquake, not a typical earthquake which lasts only 20 seconds. I'm talking about something more serious. And where can you get these serious earthquakes? Okay, I'll use this. I'll stop sharing for a moment. Right. So basically, if you look at the world map, there were so many. So basically, we have the India, Sri Lanka, and then you have Arabia, Africa, then you have China, all those places, Australia, Europe, Russia, Europe, all those large countries, and then we also have America. So here on this is the eastern coast, this is the western coast. The whole of western coast has a huge fault running from top to bottom. So here you get San Francisco, Los Angeles, and then you get Peru and all those countries, South American countries. So these areas, you get a huge fault. And if that fault ever breaks, causes an earthquake, those earthquakes have the potential to last 5 minutes. Let's hope that it will not happen. If it ever happens, very nasty effect, because you cannot be design buildings to last 5 minute severe earthquake without suffering severe damage. And fortunately, we are very lucky in countries like Sri Lanka. Our earthquakes are only 20 to 30 seconds, maximum of 20 seconds. very seldom it can go up to 30 seconds because by that time all the energy will dissipate. And earthquake, you can get aftershocks, but the main earthquake will last only about 20 seconds. And after that, you can get 5 second, 10 second, 15-second type aftershocks. But generally, what the main event will last only about 20 seconds. But there is a possibility because they are built. Americans have built some of their main cities at the wrong location. The location is the western coast. Western coast is not good for constructing buildings. So what happens is, if there's an earthquake, you have considered say 800 or 900 deep, millimeter deep. Then what happens is there will be reinforcement, you have shear links, you can't provide the links in the wall, so you have links and reinforcement, and you get cracks, and you get cracks here, because it's moving in both directions and concrete will start crushing. Concrete will start crushing. Then if the system has gone, then you add M minus NL as M1 plus M2. Now what will happen? This NL component will vanish. M1 plus M2 has a capacity, normal capacity of 5,000, and let's say under earthquake situations, when it goes up to about ultimate situation, you might go up to about 7,000. But whereas this can be 12,000, what will happen? These are not balancing. Then you'll find this is going to crack. That is at the bottom of the shear wall. Now the shear wall is failing. If the shear wall fails, what will happen to the structure? Structure will collapse. Now to avoid this situation, we provide diagonal bars. And those diagonal bars can be even ballast. You know, ballast is what you get imported from Russian bloc to make steel for in our country. We import. In the history, we used to export. Now we import ballast. Whereas in the history, we used to export things similar to ballast to the Middle East countries. That happened over 10,000 years ago. Since then, we were exporting steel, but today it has turned the other way. And that is all because, we did not pursue our stage 2 and 3 of steel cooperation that was set up in 1960s, late 60s. We don't pursue stage 2 and 3. Stage 2 is to convert all the scrap metal to steel. Stage 3 is to use iron ores and manufacture steel in Sri Lanka. That did not happen. So basically, you can use 32 millimeter diameter bars, 25. If you want, you can put it in a bundle. But to do all these things, you need a minimum of 300 millimeters. To do all these things, you need a minimum of 300 millimeters. Otherwise, there will be severe congestion of reinforcement at this place. So when you're casting, you need an opening at the side. The shuttering will need an opening at the side, so that you can insert the poker vibrators and vibrate from the side. So there are a lot of, you have to have a special opening on the shuttering. So there will be many things that you have to do. So basically, you can see it's very important that we understand all these situations. And if you think you are in a high earthquake zone, it's very useful to have these diagonal bars. Otherwise, if you think you are in a very mild zone, reinforce the beam properly and provide some bars in the diagonal direction. And knowing that you are going to need some diagonal bars, think about when you are selecting the thickness. Don't just go for thickness. Select a suitable thickness. And again, then you will say, you're asking us to make it more expensive. But what you have to keep in mind is, let's say we have some shear walls, some lifts. I mean, there's no need to have all the lifts. I mean, you can design. You don't need to have all the, because these days steel is very expensive. Concrete is also becoming expensive. So there's no need for us to, make all the shear walls out of concrete, and have some shear walls where you have the corner columns, and then you can fill it with mason. Suitable strong block masonry would give you a reasonably strong shear wall, but shear core. But no need to use concrete everywhere. Select a reasonable number of shear walls, but ensure that the building is not twisting, as I have explained last time. So it's the important point. So is that clear? Is that clear?
Yes,
Yeah?
sir.
Yeah, good. Right, okay. So basically, I'll go back to, I'll start sharing the screen again. All right, so basically what you have is these sections. So if you know the value of n, we can sort many things out. So what are things we have to design? We have designed the shear walls. To design the shear walls, we need n. We have to design the beam. To design the beam, again, we need the shear acting on individual beams. The shear acting on individual beams. And then we also need another function, that is, what is the effect of coupling action on the deflection of the shear wall at the top or any other level. So basically, we need some information, and so to understand how this works, theoretical solutions have been derived, and if you want to know the exact theoretical solution, refer the book by Alex and Cole. They have given all the information, but these days, we are not interested in all those theoretical solutions. Why? Because we have computers. So how do you model a coupled shear? If you are using SAP 2000, we allocate at each floor level, we allocate an element, a shell element. At each floor level, we allocate a shell element. By using shell elements, we can represent the shear wall. Then we allocate a beam. So if you look at beam, it has a shear force, a bending moment, axial force, torsional moment. So basically, it can move in any direction. It can move in, you can have moments, forces, all those things. So shear forces, axial forces, right? Shear forces in two directions, axial force, torsional moment, bending moment, and bending moments also about 2 axes. So it has 6 degrees of freedom, and whereas the shell element has only 5 degrees of freedom. To cater for this, these advanced programs have developed some additional degree of freedom, and they have sorted the matter out. So even without any extra element, you will get the accurate answer. But if you are using a very general purpose program where this has not been done, you need to add another beam here. If you don't add a beam, then you'll find bending moments are not accurate. But fortunately, HITAPS, Midas, Gen, SAP 2000, all have included this feature. So you can connect a shear wall, which is having 5 degrees of freedom, to a beam having 6 degrees of freedom. You get accurate answers. So we correct this. Very easy. You can easily do this. Once you define the shear walls, once you define the floors, you can easily draw the shear walls using shell elements. Then you can do the connection using the beam. So that is easy. You can all do that, but at a later day, I'll show you how to do that on SAP 2000. But once you know how to handle it on SAP 2000, you can do it on ETABS as well. But for teaching purposes, I like SAP 2000 because SAP 2000 has no black boxes. We have to do everything ourselves. So when it comes to teaching, SAP 2000 is very good. But when it comes to real practice, ETABS is better because ETABS, when you are practicing, you don't need every step. You don't have to follow every step. Certain steps can be black boxes where things happen automatically. That's perfectly okay when you are practicing. But for teaching, those things are not good because the students can't understand why we do certain things. So I like to teach with SAP, design is ETABS or Midas Gen. Midas Gen is good, but again, Midas Gen also has certain amount of black boxes. So when I'm teaching, I like SAP 2000. When I'm designing, I like Midas Gen and ETABS. They are very good when it comes to design because they can generate design reports. Again, if you ask, do you generate design reports? I would say, I'm not that keen in generating design reports because I will ask one of my junior engineers to generate the design report. My interest is mostly on the overall behavior and whether we have got it right. That is my concern. And whereas, designing generating design calculations is a routine job that you have to do, especially when you are a junior engineer. But as you become senior, you will be supervising the calculations than generating the calculations. So basically, you'll find that ETABS is a very good program, and Midas Gen is also a very good program. And if you want to know the type of programs that are used to generate or design the tallest buildings in Sri Lanka, Alta was designed by using robot in Middle East, Dubai. They use robot. But when we checked, I prepared the model on SAP 2000, and it was checked on SAP 2000. Both programs gave more or less the same answers. ETABS is little hard for that type of building because it had a diagrid. And diagrids can be easily handled by using SAP 2000, but in ETABS you might have to struggle a little bit because it's made purely for the normal building. So still you can do it, but you have to struggle a little more. So I preferred SAP 2000 to do a checking model. And then the tallest building, Twin Towers, was designed by engineer No10, and he used Midas Gen. And the advantage of using Midas Gen is, when the reviewers ask various questions, so it's very easy to generate the reports that they are asking. So Midas Gen is very powerful in generating reports for Eurocodes. So if you want to do things for Eurocodes, if you want to learn how to write calculations for Eurocodes, use Midas Gen, generate the automatic design report, see why they have generated a report like that, and then refer to the codes, refer to the books to understand the kind of calculations they have generated, the accurate calculations, see why the designer has designed by Midas Gen has produced that kind of calculations, refer to various clauses in Eurocodes. Now, if you spend about 1 year doing all these different things, you can become a master of Eurocodes. And you'll ask how I learned Eurocodes. I actually learned and taught it. I taught for 2 batches, so minimum 2 batches. I have taught. I have taught concrete design for Eurocodes. So now I can remember almost everything in it. And I have developed my own rules to deal with Eurocodes. So now I can actually do designs for Eurocode without looking at Eurocode. Right? So I have my own way of doing calculations and mostly hidden because I use my own rules, produce reinforced drawings. And if you do detailed calculations and check my reinforcement, you'll find I have got exactly the same reinforcement that you get by doing all the detailed calculations. So that's art. And when you, one day you have to come to that level where you know A to Z of Eurocode in your memory, and you, without looking at anything, you can do a design. And I can do the same thing for BS 8110. I can design steel structures without looking at codes. So basically, I have developed a set of rules. I don't look at codes when I design because all the information in codes have been converted to simple rules, the important rules, important considerations. They are all converted to rules and they are all in my memory. So because of that reason, I can design structures without needing any information. Everything can be done from the memory. That's a special talent, but that is the talent we need if you are an expert designer. So we were discussing many things on Altair with so the design engineer's pre-drug error, and I was the check engineer. We were discussing many things, and whenever we come across a problem, we do a simple calculation. We both of us will get the same answer, and then he says, you know, because we are senior engineers, we can come up with this kind of answers. But if it is a junior engineer, he will struggle for half an hour before getting the answer that we get in 2 seconds. Because they will go turn the codes, look at the rules, get the values, then do the calculations, write the calculations. They take half an hour. We take less than 1 minute. So we have checked it, and there are a few things that we did not agree. I did not agree with him, but they were not major problems. So because of that, I did not bother to complain, saying that I don't agree with you. Because one of the things that I did not agree is he said because he's having a 3 meter thick raft and the piles are there should be a slightly higher deflection at the center of the raft. And I could not figure out how it could happen, because we drilled 10 meters into the fractured rock and filled it with 60 megapascal concrete. So all the loads from the building will be directly transferred onto the bedrock. They are all directly transferred to the bedrock. Then there's no way you can have a higher deflection at the center. It will be almost the same deflection. And deflection will come due to the elastic shortening primarily because it's properly anchored at the bottom of the bottom, deep into the bedrock, very deep into the bedrock. And then you'll ask, where do you get a higher deformation at the center? You get a higher deformation at the center if you design a pile raft. That means your piles are friction piles, and piles can settle, and that can induce some deformations in the raft. And the geotechnical engineer and the structural engineer have to go through an iterative process to work out the maximum deflection at the center. It's a fairly complicated process. Again, Midas Gen is a fantastic program for that, because you'll need modeling on Midas DTX. So Midas Gen and Midas DTX are compatible programs. They are same people have written both programs. So if you want to do that kind of very advanced modeling, then Midas is a much better software than ETABS. But if if you are having 5 foundations where you don't get any extra deformation, your deformations are all based on the elastic shortening, then you have no particular advantage of using Midas Gen, but it's a fantastic program if you want to generate design reports for Eurocodes. So basically what happens is, it's a very complicated process, and I also don't do it because I do it only with Dr. Nalin Silva. Because the reason is he can handle Midas GTX and I can handle Midas Gen. But again, I'm not a very good expert on Midas Gen because I have used it. Now I have not used it for about 2 years. So I can't remember some of the commands. So I need some time before I get into it. And the real experts in Sri Lanka for Midas is actually Engineer Malit Mendis and Engineer Nuwan Senaka Vanigaratta. Those two are using Midas Gen a lot. So if you want any help on Midas Gen, you have to ask them, or you can ask Mr. Shishi. And Mr. Shishi is our Sri Lankan agent for training purposes. He's an engineer from Rookie University of India. It's one of the very good IITs in India. IITs are very good universities. IIT Madras is the best, and Rookie comes second or third. But Rookie is a very good center for earthquake research because it's in the North India, and North India is an earthquake zone. And the reason why North India is an earthquake zone is, India was not where it is today 200 million years ago. Where was it? It was in Africa. India was in Africa, Sri Lanka was in Africa. Then both India and Sri Lanka traveled a long distance. And those days, India and Sri Lanka were together during the last ice age. Sometimes it was underwater, separated. Sometimes it's all one landmass. So, and what happened was 100,000 to 12,000, those years, we had an ice age. And during the ice age, the sea level was 125 meters lower than today's. So during that time, Sri Lanka and India were all together because the sea level was 125 meters deep. And then it changed. And somewhere around 12,000 years ago, ice age ended. And something like 8,000 years ago, all the ice melted, all this excess ice melted. The world that we see today appeared only 8,000 years ago. And during that time, people have tried to build various things between Sri Lanka and India. So if you take a satellite image, you can see something looking like a bridge. And actually, when the sea levels were rising, people would have built some roads or some arch-shaped structures. So they are stable, and that's what you can see from the satellite images. So basically, the sea level has risen, and today Sri Lanka and India are two different countries. And so then you'll ask where the people lived during the last ice age. People lived in the equator belt and the Middle Eastern countries. So if you look at the history, Greece, Rome, and then we had the Egyptian and all those. And one of the things you have to keep in mind is 12,000 years ago, the average temperature of the world was 6 degrees less than today. 6 degrees less than today. So what happened was, so because it was 6 degrees less, the countries in the Middle East should have been much more comfortable than today. And those countries are much more habitable than today. So we had great civilizations in those countries. And we also had great civilizations in India and Sri Lanka. And India and Sri Lanka are the countries that exported steel to these Middle Eastern countries. And so we also had great civilization. And if you look at the carvings of Anuradhapura era, you can clearly see they are very sharp. And to create that kind of very sharp carvings, you need super strong steel. Unless you have super strong steel, you cannot create carvings like that. So you can clearly see our people have manufactured super strong steels, and even today those the swords made from those steel can be seen in some of the European museums. And if you want to know more information, just type Damascus steel and Damascus sword. Damascus steel is the steel that they sold at Syrian, the main market in Syria, that is the Damascus market. And Damascus sword is the sword that they made using the steel that we exported from Sri Lanka. And that was the best steel ever made, because the properties of that steel cannot be matched even today even with the high technology. Still, nobody can match the properties of the steel that we made in Sri Lanka. Then you'll ask, what is the secret? The secret is they use the carbon from Deodara tree, and they use to melt. They use that is the different thing. It has no bearing, but to melt, they use the firewood from Ranora tree, and to adjust the carbon content, they use the carbon from Deodara tree. And Deodara tree is a very special one. If you just put a piece of Deodara through the trunk of another tree, that tree will dry within very fast. That tree will die. So basically, we had great technology. And if you want to verify whether we had great technology or not, just go to Anuradhapura, look at some, visit almost all the ruins. Don't just visit one or two ruins. Just visit and walk few hours through the ruins. Then you can see. If you look at the sharpness of the carvings, you can clearly see these people should have had some kind of special technology that we cannot think of today. Otherwise, that kind of carvings cannot be made, and that sharp carvings cannot be made today. So that's a little bit of extra information. So basically, India was so basically, although we are here, earlier we were here. So we went through it, and then there was a burning patch here. There's a burning patch here, and all these two countries went to that burning patch, so as Australia. So because of that, all the metamorphic rock in our countries have been converted to rock, and again that rock has weathered, and it created a soil which is very strong soil that we call laterite soil. And what are the specialty of laterite soil? You get a lot of gravel, you get sand, then you get silt, then you get clay. So there are 4 ingredients. And if you take a European soil and clay and silt, clay is very high. Our clay is very low, silt is high. What is the implication of this? What is the implication of this? The implication is, if you want to do agriculture, our soil is very poor, and we have to do soil nourishment if you want to do agriculture. And because we have a lot of silt, and soil containing a lot of silt is not good for agriculture. So how do you convert it to the irrigated farming? So if you want to grow any tree, dig a big pit, fill it with all kinds of organic matter, plant a tree, allow it to grow, and then the root zone will start feeding all the microorganisms, and then you'll find The tree looks after the organisms. Organisms look after the tree. You don't need any chemical fertilizer. You can do agriculture. So the trick is you have to add layer by layer of organic matter, green color organic matter, soil layer, green color organic matter, soil layer. You build up the soil, do the agriculture, you can get a huge crop in this country. But if you don't add these organic substances, then you get very poor quality soil. Your crop will be very low. That's why when we are using chemicals, agriculture department always said, make a compost dump, add it to the soil, so that soil will remain loose, so that root zones can grow well and the chemicals can be absorbed. But that is the wrong way of doing agriculture when you are doing organic farming. And that's a place where things got wrong in our country. Last failure, crop failures are only because the agriculture department gave wrong advice. So similarly, what you have to see is, you have to understand the situations in your country. So because we have laterite soil, we have a great opportunity. The opportunity is, rather than going for huge pile foundations that are resting on bedrock and go on into bedrock with socketing, we can have different systems, and that different system is we do large short piles, and then we create cellular rafts, and then allow the structure to settle. And when it's settling, it will mobilize the pressure under the piles. These piles can be large diameter piles, and we also mobilize the pressure under the raft. So whereas here we mobilize these and we mobilize skin friction along the piles. We mobilize skin friction along the piles. Here here also we mobilize skin friction, but these piles are short piles, these piles are long piles. So both systems can work, but now we are seriously considering using this system in Sri Lanka, that is pile rafts. So we are started working on this, and we are encouraging our MSc students, undergraduates, all will be given projects on this for computer modeling. And Dr. Nalin Dizilla, who will become who would be a professor shortly, he's actually looking after all this research with my guidance. So our idea is to come up with more cost-effective foundation systems. Within next six to 1 year, we are planning to finish this work. The moment we do that, you'll find that 20-story buildings on laterite soils can be worked out, can be constructed without using pile foundations, because we can go for pile rafts where piles will be friction piles resting on stronger soils, and this will be feasible mainly at locations where the water table is very low. When the water table is very low, it will be, and then you'll ask, where are these places? Where do you get water table lower? And that is where, and now you can see our landscape is changing very fast, because we have a highway system starting 18 kilometers inland. So we have the highways going this way, we have the outer circular, we have this, and then we have another highway going that. There is Ruwanpura. So basically, the way people are traveling has changed a lot. And then we have a good train system coming to Colombo. So with all these things, now the situation is changing very fast, and where you will find future, or most of the tall buildings will come at Kadawatha, Omagama, Omagama, then Kasbeva, and all these areas like Kahatudur, and then Panadura. That is again, at the Galnigama interchange, because Galnigama is again high ground. So these are the main places where we can expect many tall buildings, many medium-rise buildings. And in all these places, we have high ground, laterite soil, and very low water table. So you can ensure you have basements, then you have foundations, but all these foundations, basements, everything will be above the water table. And the advantage of laterite soils above the water table is it's very stable material. Very stable material. With a simple shoring system, you can do excavations and nothing will settle, nothing will collapse. They are all very strong materials, and what you have to ensure is in a rainy day, you have protected the sites so well so that all the sites will remain dry, because if they become saturated, they can become unstable. So anyway, you will have a simple shoring system where you have the steel sections and then timber, and then you can withdraw the timber, and sometimes we bury the steel, or sometimes we extract the steel as well. So in this type of situation, you will ask, why basement? Basement. Why basement? The reason is, when you have a couple shear wall system, what do you want? We want a fixed foundation. It should be fixed at the foundation. And how do you fix it at the foundation? Bury the structure into the soil, and then have it on piles, some kind of system or raft or pile or whatever. The moment you have basements and bury the structure in the soil, there are two advantages. What are the advantages? The structure is firmly fixed on the soil. The second advantage is, because we are removing soil, what will happen? You can add the same weight and soil will find nothing has happened. So the stress in soil will be zero. For about 20 floors, you will find the weight of the soil removed from the basement is equal to the weight of the building you have constructed. So soil will not know that the building has been constructed. And then the settlements will be minimal. Because what soil knows is, it had certain pressure before the building was constructed. Now also it has the same pressure. The pressure has not changed. Can the soil settle? Can the soil deform? Nothing. So there's a huge advantage of using, if you have high water, very low water table, high ground, laterite soils, Sri Lanka is a perfect country to construct tall buildings. Why? Foundation cost is huge in many countries. Whereas in Sri Lanka, foundation cost can be very low. And there's another country where the foundation cost can be kept low due to very low rainfall. And that country is Australia. Where the soil is strong, absolutely no rainfall, less than 25 inches per year, unless some special event occurs. So it's a perfect country to have very strong foundations, and you can easily construct buildings with this type of innovative solutions. And we are developing it. Nobody has ever done this kind of solutions. We are developing those, and in the next 1 to 2 years, we publish heavily using this material. And if any of you are interested in doing some research on this type of topics, you can contact us and we see the possibilities. We can't guarantee, but we can see the possibilities. So when you have coupled shear walls, you have coupling action, and whole thing behaves as one unit. And when you do that, I showed you how to do the modeling. But now, if you don't have SAP, how do you do the model? And how do you do the model is, we create a B column, we create another column. Then what we do is we create a strong arm of this leg. Then we create the real beam, coupling beam. So how do you create a strong arm? Strong arm is created by using a beam where I value is you allocate using set modifiers in the structure, in the facility. You can modify the properties of the members by using set modifier. And what you do is you use set modifier and convert it to a strong arm. Strong arms can be used very effective. And you have to learn how to use strong arms even when you are using SAP 2000, because if you have a transfer plate in the structure, you have a wall here, Whereas the center of the structure is here, the wall is acting here. It can give a torsional moment. How do you model it? So in the model, you model the center of the beam, and the wall is here. So to ensure that these are connected, use a strong rigid arm. You use a rigid arm, you use a rigid arm, and support the wall here. So what will happen? The load is acting here, it's a rigid arm. This angle remains 90 degrees. So you can get the torsional moment acting on the beam. Torsional moment acting on the beam. Just go through the note, sorry, the presentation that Engineer Kamala shared with you. And there's, you can see some structure has been modeled, a transplate has been modeled. And when the transplate was modeled, rigid arms had been used. Rigid arms had been used. So just go through that presentation. And if you have rigid beams, trans beams, this can very easily happen when the walls are not, they are on the wall, but not at the center. Because walls will be selected by the architect, because architect will have their own requirements of partitioning. So we can't have the walls always on the center of the beam. Sometimes they can be little away. And because this is a transom beam, we make sure the depth X and the width Y, they are more or less the same. Then you'll get the highest torsional moment resistance. And sometimes we deliberately make them wider to ensure some of these walls that are at odd locations can be brought onto the wall rather than putting various additional members, because every additional member means some additional work at the site. So you have to always ensure that your models are accurate. So that's why I taught this rigid arm concept, because otherwise, in SAP 2000 you don't need it, but here you need it because you are dealing with rigid arm concept. So you can see now when you are constructing Colombo, very weak soil conditions, because Colombo is one of the useless places to construct tall buildings. It is not the ideal place, but still, you go to Colombo today. If you haven't gone to Colombo last 3 years, what would happen? You will not be able to find many roads that were known to you because they have all changed. The flyovers are coming up in the next 6 months to 8 months. We'll find all these flyovers have been completed. And then you'll find railway crossings are no longer there. You'll always go on the flyovers, and because at Naumouth an area, there are many crossings, and all those crossings will vanish because there will be flyovers, and the Colombo will be a completely different place. Within next 1 year, you'll find it is a completely different place, because now Maga Engineering is given the contract to finish most of these flyovers with some other contractors, and they are working very fast. If you go to Slave Island area, you can see there are road closures, all kinds of changes. You cannot recognize any road that is known to you, and everything is going to change. But Colombo is not the best place in Sri Lanka for construction of medium to tall buildings, and the Homagama area is very good, because that area you have a lot of get very reasonably high elevation lands. Then Kadawat area, again you have high elevation lands, but between Homagama and Kadawat, the areas, there can be some pockets which are good. But the problem is there are few interchanges like Kadwela, Kotalawala, Aturgiri. All three, Kotalawala is okay, but Kotalawala is a half one, not a complete one. But even Kotalawala access is can be inundated close to the Malbe town. So because of that, because of the flooding that is caused by Kalani River, Aturgiriya, Kotalawala, and Kadwela interchanges are not the best places to have this kind of development, whereas Kadawata and Homagama and Galnigam are the best locations. Kahatudu and Galnigama. They are the best locations for the future development and expansion of Colombo city, because the moment we construct a very large car park, multi-story car park, in multi-story private car parks where you have to pay and park, but concessional rates, then you can promote people to come to Makumbura, interchange, the main transportation hub, and then take a train and go to Colombo. And that's a kind of a situation that will happen. And in addition to that, when you're living in any of these locations, you can get into the highway and travel to Katargama in 2.5 hours, Anuradhapura in 3 hours, Kandy in 2 hours, Jaffna in 6 hours, and Trinco in 5 hours. And how about Betiklu? You go via Mattala, 4.5 hours to Betiklu. So the moment you have all these highway links, even today it's possible. Most of these links are over except phase 1 of Central Highway. And once the phase 1 of Central Highway is done and the Galagedra link is done, then Kandy will be even less than 2 hours. 1.5 hours is our target. And then because from Galagedra there are links to Peradeniya, and if you go straight you can go to Katugastara, otherwise you can go to Peradeniya by taking, there are so many roads to Peradeniya. From there you can easily go to Peradeniya, and once you go to Peradeniya in 2 hours, then in 3.5 hours you will be in Nuvareli. So you can go to Nuvareli in 3.5 hours, and you can shorten it to 3 hours once all these links are completed. In 2 years time you will go to Nuvareli in 3 hours. So these are all scenarios, and with those scenarios, what can you expect? We can expect a huge development of tourism in Sri Lanka, because if we protect our environment, we become concerned, we don't pollute it, we look after our environment, Sri Lanka can easily hit 10 million tourists per year. And the moment we do that, you will find absolutely no chance for any kind of dollar shortage thereafter. So these are kind of development you can expect shortly. And you can see we have wonderful beaches on eastern coast, best in the world, some of the best in the world. And then we have huge beauty in the upcountry, and we have our ruins, everything, very attractive things in the north central province, and we have very nice road network without much roads, much vehicles, even today. And so we have good road network because we have coastal roads, we have middle roads, Giranduru Kotte, all those areas. And now we are in the process of actually working out the missing link via Murthu Lagoon, which will need a 3.5 kilometer long bridge and another 1 kilometer long bridge. And both are on the pipeline. Shortly they will happen because funding is available through Hungarian agency. So a lot of things are going to happen in Sri Lanka. With that, you'll find there's a huge market for tall buildings, medium-rise buildings, especially in these areas where the soil conditions are very good. And with that, what do you expect? We'll have to design more and more buildings. And what I do is I'll share the screen again. And if you go further down, you can see I will post this. I will share this note with you, and if you can work out based on the areas, lengths, the second model area, all those information of these walls, you can work out some alpha and k parameters, and then you can easily work out once you know the moment is moment of a cantilever is given by this moment of a cantilever is given by stop share again. Moment of cantilever is given by this W and this H, W times H, and acting here times H by 2. Or you can use, depending if it is not uniform, you can break it into pieces like this, bigger one, smaller one, smaller one, smaller one. You can find the total moment here, you can find the total moment here. Then you know the moment, external moment, and that external moment is this one. And when you know the moment, you can you know the moment, and but if you know the value of n, then only you can work out m1 and m2, because m is equal to, here you can see, m is equal to m1 plus m2, m is equal to m1 plus m2 plus nl. You know that you can find the external moment. If you know the value of n, you can find m1 and m2. So to do that, what you need is to find n. And how to find n? What you do is you can calculate an f1 parameter based on k alpha h and z over h ratio, and any level you can find that. So this is f1 from this chart. Calculate this parameter, and w is known, h is known, k is known, but these charts are actually derived for uniform pressure. But in actual situation, we can get variable pressure. That's why we go for computer program. That's why we use software, because these are general solutions. You cannot work out theoretical solutions for very complicated things, whereas computer software can easily handle very complicated situations, because we use finite element analysis. So basically, you get this n, and then if you want to find q, you go and see this one. Sure. And then I'll handle, please don't handle my camera. So the host is wanting to handle my camera, I don't want it. So basically, if you want to find the deflection situation, you can see the deflection can be as low as 20 to 30%, because this parameter will be 0.3, 0.4, 0.25, that type of range. So you can see there's a huge advantage of using coupled shear walls, and I have given a design example based on this. And Engineer Kamala, I can actually share this note so that I will actually email this note to Engineer Kamala. I will share it and compose subject from Professor and then Engineer Kamala, Manjula.
Excuse me, sir. Kamala madam told me that Due to the power cut, she couldn't be able to continue the lecture.
Right. No problem, because I'm just sending. Who is this Karte?
Yeah, yes, sir. Karthikeyan.
Yeah, Karte, what's your email, Karte?
AR.
I'm saying, yeah. Can you
sir.
arrange? Can you please ensure that it is shared now?
Okay, sir.
I'll put it.
Okay, sir.
Manjula, I'm sending, and no. Okay, so I'm forwarding the file.
Okay, sir.
And Manjula and Kamala. Okay, it will come to you. Parthe, see, can you see and can you arrange, make arrangement so that you are sharing the note, please?
Okay, sir. I'll arrange it.
Yeah, so any questions, chats, anything you have? Oh, I have 11 chats. Let's see.
There is one
Share
question.
the presentation. What are those? Dear Professor, yeah, okay. Provide diagonal bars about the core wall openings. What is that core wall? Yeah. Core wall openings, yes. You have to provide these diagonal bars when you have core wall openings. You can, but in not in simple buildings. But if you have a very, tall building, provide it. But if it is a 10-story building, no need to do that. 10, 15. But if it is a single, very serious building, and you expect, you want it to be super strong, absolutely no risk, then provide all these additional bars. Karthikeyan will coordinate. Yes, and core openings like lift openings. Sir, what about Autodesk robot? Yeah, robot is good. It's okay. I mean, you can use it. Robot was used in Altea. And please provide us with presentation slides. Yes, I'll give the note. The presentation slide is the presentation. The video of the Zoom link will be uploaded, and register for the event of ISL website. How can I receive PPT? If you have not registered, I actually don't know. But if you contact Karthikeyan, Karte, can you type your email on chat, so that they can send you an email and you can forward anything. Anybody who is not registered, they can still get all the information, right? How about Karnataka for such developments? Yes, it's possible. Karnataka is higher. Some areas of Karnataka are actually very good laterite soil areas. Yes, you can. And Karte is karthe@gmail.com. Karthikeyan is, the name, another name for the god Khataragama. So Karthikeyan is karthe@gmail.com. He's actually doing his MSc full on with me and some others. So right, okay. Who is this Jaya Sundara, JMAR Jaya Sundara? So you can take your email, Karthikeyan's, and
Yes,
then
sir.
send an email. If you are not registered, you can send an email to him. He will forward the information. Right. So basically, I don't see any special questions, but the most important thing you have learned here is how to use rigid arms. The concept of rigid arms. The concept of rigid arm is so important because the rigid arm can be used in many situations. And when you are doing modeling, rigid arm is a very valid concept that can be used extensively. When you are facing very complicated and difficult modeling situations, you can simplify those situations very easily by using rigid arms. Karte, do you have any questions, or anybody else having any questions? You can ask the questions now.
There is no questions in the chat box, sir.
Yeah, no questions. Yeah, only comments. Yes, but what you can ask. I mean, if you have any questions, you can ask, because we have few minutes more. Then I will tell a few things because Engineer Kamala wanted me. Because we are planning. Still, we could not get the permission for this particular thing. That is, to those who have registered and attended. We are working on it. We'll get the permission from the council so that the fact that you have attended this particular lecture series with more than 80% attendance, you will be able to consider this the participation of this as a fulfilling requirement when you apply for licenses to certify buildings. But because of that reason, those who have registered, we like you to give few assignments, and I will give simple assignments where we will set the assignment in such a way that you have to go through the earlier notes and go through the notes and answer the questions. They are simple questions, but there could be some tricky questions as well. So you have to go through the notes, give examples, and show that you have to show that you have knowledge knowledge, because you have grasped most of the information that we have taught. So we are doing that to help you. So if you complete all these things, we will ensure that from the Civil Engineering Sectional Committee, we will give you a certificate at the end of the series, saying that you have attended this with more than 80% attendance. And that's why we like you coming through the registration process. As number one. Number two, these days, many people are facing a huge power crisis. And Karte, I will send you some WhatsApp message. Can you see whether you can share with with some of the participants? You can. I mean, I don't know how to do that, but sometimes you might be able to load it to some site so that these WhatsApp messages can be seen by many others. The reason is we have developed some very useful solution for this power crisis by taking out most of the houses and buildings off the grid during the daytime. So I will send some Karte, yes, I'm sending it to you, Karte. Karte, can you arrange it?
Yes, sir.
Yeah. So I will send it to you, and it gives very useful information and some contact details as well. And so you are receiving it, Karte?
Yes, sir. I received.
Yeah. So it has all the information. If you can put it to some site or convert it to a one document or report or something, right?
Okay, sir.
And then share with all the people, because it has all the details, some extra details, but it doesn't matter. I mean, no harm. You just have to read it, but it will tell you how we can easily solve our problem short term. I'm not talking about very long term solutions, because first thing is to overcome, if you have a problem, overcome the problem short term. Once you overcome the problem, now you have time to look at it logically and in a more planned manner, so that you can come up with the long-term solutions, good long-term solutions, which will not increase our carbon footprint, but still give us enough electricity. So it can be renewable or it can be anything, but somebody has to do a detailed study. But the most important thing is if we can avoid power cuts in the next two to 3 years, then we are through. And for that, I have developed a solution. That's why I was very busy this morning, and the whole day I was working on it, and now I have developed all the information so that you can easily go through it. All the information is there, contact people are there, and with all that, ensure you will be basically it will all help you to understand. And sometimes you might be able to easily take your homes out of the system. The idea is, from 7 o'clock we have sunlight, so the whole day we have sunlight, and we stabilize the system by using battery backup. and we use fridges, some bulbs, fans during the daytime. We run the system whole day time. In very few days of the year, only we have thick cloud cover. Other days, it might you might have hazy sunlight, so it can generate. But other days, you have rain and then again sunlight. We don't have continuous rainy clouds all day. Gloomy days, those are missing in Sri Lanka, especially in dry zone, wet zone, everywhere except the central hills. We get plenty of sunlight. So we run the system, and then by evening, all the batteries are fully charged. So we run the evening peak on batteries, and we find that the batteries become weak around 8:39, depending on the usage. And if the usage is high, we'll increase one or two batteries, improve the storage so that we can go until 9 o'clock. And after 9, our evening peak starts vanishing because people start sleeping and the usage becomes lower because the cooking, everything will be over by 8:30. Most of those activities like boiling water, all those things would be over, they come to a low frequency. And with that, we'll fast approach the base load. And as the whole system is approaching the base load, we also get ourselves corrected, but we operate, somebody's working late, we might have one laptop with one bulb or two bulbs working, so very low energy consumption. That will help us sustain the base load. And then the whole day we have been away from the system. So CB will find it's very easy to manage the system because no customers. And CB has to generate only little electricity. And CB, the situation in CB is more it generates, more it loses. So if CB can reduce what it generates, it can be easily made a profitable organization without increasing the tariff. So I have given some plan, and we all know Sri Lanka is an ideal country for rooftop grid connection, but CB was a little reluctant to get us all on the small rooftop people onto the system, because they found that sometimes it's a little difficult to manage manually. Unless you fully automate using artificial intelligence software where it gathers huge amount of data and make very quick changes, decisions, then it might work. But otherwise, CB finds that, it's not that easy to manage the situation where everybody is generating and feeding the national grid rather than using the national grid. So what I suggested is taking all these customers who have about 5 kilowatt rooftop, take them all out of the system and make them off-grid autonomy, or they are not relying on the grid, off-grid autonomy, and make them run the system throughout the day, and they connect only to support the base load. Any rainy day, you don't have to go off grid, you can remain in the grid, because rainy days means we have plenty of water in the upcountry reservoirs, and we can use the reservoirs the maximum level to generate 60-65% of our need can be generated using hydro, because it's raining and all this water can be used to generate hydropower. So the moment we generate hydropower, we can feed, no harm in having a lot of people, but at the same time, in the long run, we'll have to go for LNG, liquid natural gas, LNG, because LNG does not add to the carbon footprint very much. So basically, we'll have to do many things future, but short term, the solution that I have worked will work will be a very effective solution. And I have given the example because we got it installed recently in one of the houses of a relative. And today I went there and got it videoed. We got a video, and then I uploaded this video to your WhatsApp. so that many of have seen the video, and so I talked during the video so that you can hear what we are talking, so that it's all recorded, and then accordingly then I wrote the information. So, and also if you want to get information on how to do it, I gave those information as well. So we can go off grid the moment we all become grid independent. During the daytime, grid can serve the poor people who are unable to have rooftop solar, and also paying very little fee, little charge, monthly charge. So nobody wants them becoming solar people. They can be on the grid because our grid can support that type of very small users. But what the grid cannot support is huge consumers. And the moment grid CEB tries to satisfy these huge consumers, because as huge consumers, we are not paying enough, and we are having a lot of diesel capacity, which is very expensive, most refined form for electricity generation. Then what happens is we need something like 60-70 rupees to generate one unit of electricity, and which is about 30 to 35 US cents per unit, which is a very expensive value. So basically, many people can go for this grid autonomy and take them off from the system. The moment you do that, what happens is the demand will go down, losses will be minimum, CEB will become a profitable organization, and there can be some tariff adjustments to encourage people to go for off-grid. And with that, a lot of people will go off-grid, and they will have a capital investment, but the electricity bill will be only about most probably less than 1,000, unless you are using air conditioning on the system. But daytime air conditioning, if you need, it's wrong to use air conditioning during daytime in Sri Lanka, because your houses should be planned in such a way, and there are so many water heat reflective films and a lot of things are available in Sri Lanka to reflect the heat back, and one of those heat reflective films are made by Dr. Leslie Ekanayaka. He has a factory, and Note 714212355. I see this is number Note 714212355246810. Yes. Note 714212355, and so basically you can contact him, and there are heat reflective films. So this basically you don't have to use the air conditioners because they are not very good for health. So if you can avoid it, always live in a free running building, you will be healthier. But at the same time, if you want to use the air conditioner, because you have rooftop solar, you will be able to use it, and the changeover is also can be fully automated. So you don't have to think who is giving electricity, somebody will give electricity, but mostly by the solar, rooftop solar. So basically you will be having a very nice situation, and all these batteries will be hybrid type. They are more expensive, but they are very hardy. And basically once you stabilize the system by using hybrid batteries, you don't have to worry about anything. So with that note, I will end the lecture, and Karte will share whatever the information. So use Karte as the the contact person. And Karte, you have given the email and then your telephone number. Do you like to give, Karte?
Yes, sir.
Can you type it, please?
Yes, sir.
So, Karte, can you form a WhatsApp group?
Okay, sir.
For this sharing the information? Then it will be easier, right?
Okay, sir.
You have typed everything in one go. What is this membership? You are a member.
No,
Ah,
sir.
no, somebody.
I didn't.
Somebody else. Yeah. Karthik can't be a member because after graduation he has gone to India for 3 years to learn Hinduism. Is that right, Karthik? 3 years.
Yes, sir. 3 years.
3 years in India. And he
There are
has
some
learned
questions, sir.
what?
There is a question asked by.
Karthik is 07645335577. So send him a message, then he will add you to the WhatsApp group. Send him a message, he will add you to the WhatsApp group. Okay? Is that correct, Karthik? Send him
Yes,
a
sir.
message, he will add you to the WhatsApp group.
There is a question.
Yeah, what is the question?
Many architects now tend to request columns with 200 millimeter width. I have seen during the site visit reinforcing those columns nearly impossible at joints where all beams slabs. Can I get your opinion this matter?
Yeah, of course. I mean, tell the architect, you can't do it. That's it. Tell the architect, don't do things which will make construction of the building impossible, right? Because architect can do it, but the structure belongs to the structural engineer. So structural engineer says, don't do foolish things which will make the construction almost impossible. And also detailing so difficult. Don't do this kind of foolish things. You just tell it. That's it. And when every engineer is telling that, United and telling that, minimum thickness is 225, it becomes 225. Right? 25 millimeters can make a huge difference because that 25 will give enough space to insert the normal poker vibrators. Otherwise, even the poker vibrator cannot be inserted when you have 200. When you have thick, strong walls with, a lot of bars. So basically, I mean, in a tall building, I will go for 300. This is a significantly tall building. I will not go for 200. I will say, whether if you don't.
The other question is it wrong to design shear walls floor by floor?
Sorry? It is? Karthik, what is the question? Is it in the chat box? Where's the chat? Chat is empty. What is the question, Karthik?
I think he lost the power. He faced with the power cut.
Yeah. His phone went dead. Anyway, do you know the question?
Sorry, sir.
What is the question?
So is it wrong to design the shear wall as a column floor by floor?
What do you mean by that? Yeah, floor by floor. Yes, you can do it. No problem. You can do it. Column as a column, floor by floor. Yes, no problem.
And there was one more question. When concreting column and beam with different grade concrete, what is the grade that we have to use at column junction?
Basically, you can have, because you have heavy confinement of reinforcement, confinement due to reinforcement at the beam and the column, the grade the difference in the grade can be 10. If the difference in the grade is 10, no problem. So we're using 40 megapascal for columns, 30 megapascal for beams and slabs, no problem, nothing will happen. But what I do is to ensure that one day all will become equal. When I'm using grade 30 concrete, 30 megapascal concrete, I will use minimum of 50% fly ash. The moment you do that, in 30 megapascal concrete, initially you get the strength, you continue the construction. And as the building is completed, the beam concrete will also gradually reach 40 megapascal. So your requirement is 30 megapascal in 28 days that you achieve with the minimum cement. Because there's fly ash, the situation will not stop there. It will continue. And one day, though when you are designing, you have used different values, the flow concrete, the beam concrete, all will be 40 megapascal. Though you were casting it to be different at the 28 days. The 28 days strength can vary, but the final strength can become over 40 if you have used 40 and beams and stuff also reach 41 day. You cannot have any kind of. Did I answer the question?
I don't know, sir.
Yeah. Karate, I also want the copy of this, whatever the link. Can you, you have the recording? Who is having the recording? You are recording, Karate?
No, sir. It's recorded by the host. Yes, sir.
Yeah, yes, host. Get a copy from the host, and can you send the WhatsApp link to that, whatever it is? It's very
Okay, sir.
useful.
I'll ask Kamala madam and I'll coordinate with him.
Yeah. Okay, please send it by tomorrow, if possible.
Okay, sir.
Right, okay. With that, shall I end the lecture?
Yes, sir. Now I would like to call Engineer Renuka here to deliver the vote of thanks.
Yeah, okay, thank you.
Good evening to everyone. I get this opportunity to thank you all on behalf of Civil Engineering Sectional Committee. Thank you very much, Professor Jai Singh, for your informative and detailed presentation. You are always ready to share your knowledge, dear sir, to encourage our engineers and motivate them for CPD activities. As the chairman of Civil Engineering Sectional Committee, you are doing a remarkable job, sir. Thank you very much again, Professor, for sharing your knowledge and valuable experience with us. Thank you very much, Professor.
Okay, thank you very much. Thank you. Thank you.
Welcome, sir.
Okay, thank you.
My special thanks goes to...
No, I told you many things, many background things today. And I hope that will all be enlightening, because when you know a lot of background information, you can always make good decisions. Okay, thank you very much. Thank you. Bye.
Welcome, sir. My special thanks goes to Engineer Kamala Gunawardana, member of Civil Engineering Sectional Committee and Chairperson of Knowledge Sharing Subcommittee, for getting webinar arrangement successfully. Then also I thank Engineer Manjula and the team for supporting arrangements of this lecture series. My sincere thanks goes to ISL Secretariat and IT team for publicity and hosting arrangement. Last but not least, I thank you all for active participation. And without you, we can't make this event success. We expect your active participation in upcoming events too. Have a wonderful evening to you all. Thank you. Thank you very much. Good night.
Thank you very much.